Here's 3523. A layer of water, index refraction 1.333, floats on a container of carbon tetrachloride, N equal 1.461. What is the critical angle at the interface? So we have an interface between water, let's call that N1, 1.333, and carbon tetrachloride, 1.461. And we're going to have a critical angle, which means we're going to have total internal reflection. However, it didn't say which substance the light is originating in. However, to that, we know that in order to have total internal reflection, we have to go from a higher index to a lower index. So our light has to be originating in the carbon tetrachloride. So I'll have some kind of angle of incidence, which I'll call theta 2, since my carbon tetrachloride was substance 2. And it's going to refract away from the normal in the water. In fact, in this case, we're looking for total internal reflection. So our angle of refraction is going to be 9 degrees. We want to find the point at where we don't get anything refracted. So we have an angle of refraction 9 degrees such that everything will be reflected with the same angle, theta 2. So it's a Snell's law problem, and we have N1 sine theta 1 equals N2 sine theta 2. In this case, we're actually originating from 2 to 1, and we want to solve this for theta 2. So theta 2 is going to be equal to the inverse sine of N1 divided by N2, as I've drawn it, sine theta 1. So our second substance is the N1. So we have the sine inverse of 1.333 over 1.461 sine and 9 degrees for angle of refraction. Sine 90 is 1, so we have just the inverse sine of the lower index over the higher index. 1.333 divided by 1.461 inverse sine is 65.8 degrees. So the angle of incidence, the critical angle at the interface, is 65.8 degrees. At that critical angle and greater, all the light will be internally reflected from the carbon tetrachloride to the water. 65.8 degrees.